Welcome to the lesson 14 of the Advent of SysML v2. This is a training series consisting of short videos and exercises brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kęstutis, and today we're going to recap week 2, everything we learned in lessons 8 through 13. We learned how to organize models, share them across teams, document them effectively, and connect model elements at incrementally increasing refinement levels. Week 2 started with a fundamental question: how do you organize models as they grow? In lesson 8, we've learned that packages solve two problems: model element organization and name collisions. Packages work like folders. They group related elements and create namespaces. SysML v2 gives you multiple naming options. Qualified names use double colon to navigate hierarchies, like entities, : reindeer. Short names in angle brackets provide concise identifiers. Unrestricted names in single quotes allow for use of special characters. And aliases let you rename imports to avoid name collisions. For imports, remember the best practice: use private imports by default and import specific names when possible to avoid namespace pollution. In lesson 9, we introduced Sysand, the first open source package manager for SysML v2. And here's connection. SysML packages organize model elements within a project, while Sysand packages manages dependencies between the projects. Same principle, different scale. This solves real engineering problems: version mismatches across teams, duplicated modeling effort, and difficulty enforcing standards. Whether for design reuse, compliance, or supplier integration, package management brings software engineering discipline to systems modeling. In lesson 10, we covered comments and annotations. Here's a critical distinction that can be missed. Notes with double slash are not stored in the model. They are like code comments, useful for to-dos and structuring your text files, but they disappear when the model is being parsed. Comments with / are stored in the model. They are extractable and can be about specific model elements. Documents with the doc keyword document the element they are nested in. They support locales for multi-language documentation. And textual representations let you store information in domain-specific, natural or artificial languages like Python. What makes all of this so powerful? Documentation becomes extractable data. You can generate reports, check translation coverage, export to other tools. Your model documentation becomes part of your engineering workflow. In lesson 11, we learned about attributes and quantities. Attributes are fundamentally different from parts. They represent abstract concepts such as numbers, colors, enumerations, things without identity. The number 5 is just 5 everywhere. Nobody owns it. That's why attribute usages are always referential. Enumerations restrict values to a specific set of choices, like our color enum with red, green, blue, and other specific options. For physical properties, we use quantities. Here's the choice: use subsets to say an attribute is kind of a quantity. That's safer, allows other kinds. Use redefines to say it is the quantity. This explicitly prevents other kinds of the same quantity. Feature values allow you to specify values of attribute usages and all usages in general. There are two important aspects: initial versus bound. This constrains value at the beginning of owner's lifetime or for the entire lifetime. Default versus non-default. This specifies whether the value can be overridden in specializations. And remember units in square brackets. The language handles the conversions automatically. 110 kilograms equals to 110,000 grams. SysML knows that. Lessons 12 and 13 cover the most powerful concepts from week 2. Connections enable you to establish bidirectional relationships between model elements. The end keyword marks the connection's ends, what's being connected. Cross-subsetting with crosses keyword enables navigation. When you write sleigh crosses reindeer.pulling, you are saying, when connected, access the sleigh through the reindeer's pulling feature. Cross multiplicities specify the number of elements required on one end to connect to the single element on the other end, not the total number of links. In connect 1 sleigh to 9 reindeer, the numbers come before the feature name. 1 means each reindeer connects to 1 sleigh. 9 means each sleigh connects to 9 reindeer. A single link is always connected to exactly one element on each end. In lesson 13, we dive deeper into connections topic. We introduced ports, which are dedicated interaction points. They expose features without revealing internal details of components. Conjugation, using tilde character, flips the direction of port features. Use the same port definition on both sides. Conjugate one for compatibility. Interface, connect ports. Items specify what's being exchanged. Flows describe the actual action, the act of item transfer from output to input. Here's the key insight for modeling connections. The hierarchical refinement pattern. On the entity side, we model at 3 levels: parts, then ports of those parts, then items exchanged through the ports. On connection side, we mirror this: connection definitions between parts, then interfaces between ports, then flows between directed features. Each level refines the one above. The result? A recursive blueprint. Define once, instantiate many times. Every connection automatically contains the interfaces and flows inside. So to summarize, week 1 taught you what systems are: parts, features, specializations. Week 2 taught you how they work together. You started with isolated definitions. Now you have interconnected architectures, packages that organize, documentation that travels with the model, quantities that ensure precision, and connections that automatically set up their internal structure. That's the shift from describing parts to orchestrating systems. Your challenge task for today is to practice the shift towards orchestrating systems. Take the Santa Elf workshop model from previous lessons, reorganize it into packages, add documentation, give it a real quantities with units, connect components using the pattern we learned, and build it as a Sysand package. Check the blog post for more details. Share your experiences and feel free to ask questions in our community forum. All links and information is available in the video description. Like, subscribe, and click the bell icon to get notified about future lessons. Take care and happy modeling!